Welcome to the lecture series on object oriented analysis and design. Today we are going to focus on a language called Smalltalk. While we have acknowledged that the overall topic object oriented analysis and design for this series includes many things, of which programming and therefore a programming language is one essential component, one essential aspect of learning. However, the core advantage of object oriented analysis and design has been to move many things to the design phase. That is, before we talk about programming, we should have done more work on the design phase, because we want to do the top down analysis, and at the earliest we want to see the bottom up structures coming in place. Both should happen simultaneously. Design will remain the fulcrum, like in many other engineering disciplines. Even in software engineering, design will remain the fulcrum. However, software engineering has been a very distinctive field that is not guided by the material senses, which are so essential in other engineering disciplines. So, we have so much of plasticity, we have so many changes. In summary, if 30% of the requirements are stable, we have done a very good job in the design. It is automatically implying that the design is good, and therefore, whatever happens after the design is also reasonably good. We do not have too much of errors towards the fag end of deployment or whatever it is, the other phases. So, what we have done essentially is everything should become visible at the earliest as how the software will eventually begin to happen. The bottom up is what is the approach that we talk about. Very soon we will see that there are independent components. When put together, it will happen. Yeah, it will happen correctly. You should be able to anticipate. There is some component missing. If it comes, it will happen correctly. How do you know? So, these are the simple questions. There is a flat tire. If the tire is repaired, it will happen correctly. The car will go, the scooter will go, the cycle will go. How do you know? Well, call it past experience, call it whatever it is. There are so many components. We know that when something goes wrong, if we do that, it will be functioning correctly all along. So, this is where we have been talking about sensing all this at the design stage. The moment you sense that this kind of a design is flexible, this kind of a design is extendable, then we keep talking about the way we progress. Looking at the design, I can tell where is the deployment, what will happen once deployed. Most of the time it is fine. In many engineering disciplines we are talking about, there are very concrete design rules where we can foundationally verify. However, one of the lectures we have seen, the verification and validation is itself difficult. Since the object identification and design has been that crucial and that complicated, and we are not too sure where exactly we are landing, we have taken recourse to what we called object oriented analysis and design methods. There were too many. To cut the long story short, by around 2000, early 2000, we arrived at what is called a unified modeling language. That in itself is not a programming language. Now, please understand that the very methodology of software development is to take whatever we want to do out of the context where it has occurred. There are so many disadvantages in that, there are so many perils in that, but then there is the most pragmatic way of taking everything to the machine without getting more and more into the diffused workspace of people, because nobody is too sure. That is why the requirements are volatile, 70% of the requirements change. So, we have been talking about craft, we have been talking about skill. In summary, all this is business idea to operations. If they are so crystal clear, if everything can be tasked, it keeps on happening. But then when something untoward happens, maybe we are not so well equipped to anticipate what is going to go wrong or how much of damage can happen. We will have to find out more about what is it that has led to the development of the business idea into the operations. Nothing is completely new, but our development methodology, which is based on software, is intellectually challenging and stimulating, because it is one technology that is promising to take you more and more into the realms of complexity. That is where we thrive. We have a way of talking about the development process. This is true, this is necessary in every business. Business idea to operations is very obvious. Business development, it has to take a different cycle. So, what we did was, it is good that we have unified modeling language that takes us very nicely up to the design phase. After that, what we were talking about, we were simply talking about pressing a button, and depending on a language selected, the code will come and it should operate automatically. They are also pieces of software. All the comments that we are making on the software, pieces of software, hold good for all other tools. The tool dependency, this has been a study in itself. There's a nice, there's a good discussion we had on case tools. All these have been a matter of debate, matter of concern. Now, with the businesses becoming very stiff on the time and cost lines, we have been having no choice but to take recourse to tools. However, we all know that the perils of lifting anything out of the context require more skill. In the context, it becomes obvious. People are there to ensure safety. People are there to manage things. So, when you are taking it out of the context, where virtually it is a sort of Greek and Latin or a geek's language of development platform, we need to understand that there is a discipline necessary to handle things out of context. That discipline began to be called as programming. There is a way in which you have to think about it. We know we are out of context, and therefore, we want an idea called programming to happen. We talked about programming languages, all ensuring that whatever we have plucked out of the context is retained in its intent. The intention of doing it is retained. It is absolutely necessary to understand that we need to understand the intent and preserve the intent. That is when that context freeness will yield. Otherwise, it can be perilous. We cannot simply pluck things out of the context. So, what is that discipline? We said that let there be programming, we talk about complexity, we talk about the intent. We should know what is the intent at the time when we are bringing it out of the context, preserve the intent till the end, then it goes on to the machine, and then there are good chances that whatever has gone on to the machine, tested in our place, in our space of operations, simply goes back to the stakeholders. Into this, during the earlier lectures, we have seen how the dynamics have gotten in, multiple stakeholders, multiple domains. So, we are quite happy to a point where OAD became synonymous with UML, but then it is just there. UML, it has become synonymous with OAD, and there is a set of tools, the rational tools, about a score of tools, about 20 tools were discussed. So, we are not disputing the fact that it was a wonderful progress OAD has made, particularly when it was brought in very late 90s, almost at the brink of breakdown in software. OAD as a technology idea came up. Next 5 years vigorous work leading to not much of a spectacular success as it was expected. As a matter of fact, it was a reported failure. Object oriented requires completely different thinking. Now, it is a matter of a wonderful progress in the next 5 years that gave us UML. Once OAD began to become synonymous with UML, lot of tools, plenty of thought has gone behind. It's a fantastic stretch for 20 years. Till today, we are talking about OAD that is addressing a very good range of applications till today, which are nicely built, extendable. The more complexity you want, the more we have. It appears a very promising idea, but then it pays back only when we are talking about a reasonable degree of complexity. The skill sets required are high. So, up to programming it is fine. We said that let there be those disciplines which are necessary when you are picking anything out of the context, and once you have picked everything out of the context and then got into a programming shell, moved into software engineering to anticipate. Programming is more an exercise where we start and stop, and we know that for certain inputs there can be bugs, we should know how to debugging. Software engineering takes us many miles from here, it is many miles away from simple programming engineering. we keep talking about quality, we talk about anticipation, we talk about quality factors, process, system, life cycle, principles, the idea of software engineering that has happened 70s, let us say 68, 69, let us say 70 is now 5 decades old. It has been a spectacular growth in the field of software engineering, very spectacular, just 50 years and we have done so much. Software is everywhere, all domains have software, to a point where we think that the best way in which we can tackle interdisciplinary, multidisciplinary with a reasonable degree of assurance is software. Today we can build all of them together. So, I have said the same, that UML is good, it is a modeling language, there is a tool. However, we cannot forget the programming languages. OOAD still thrives on programming languages. There are so many schools that keep talking about a very simple way of comparing this many number of languages based on certain concepts. Good number of schools, there are good number of schools against this also. How do you decide which language to teach? For so many years the debate goes on saying that should we teach a programming language at all? It should be learned, solve a problem, abstract the problem, convert it into a program using a language of your choice. The syntax is standard, the grammar is standard, we have good books, good lectures on compilers, we know how to construct a compiler. There are very many compiler construction tools today, Lex and Yak were very famous. So, you can look at the context free grammar, the theory of computation which has nicely settled, not only talks about the Turing machine, but also the related aspects of compiler construction. We understand that a context free grammar at that abstract level will work as it should on a Turing machine within the ambit of a Turing machine. However, there are so many languages. There was a very good paper by Landin, 700 languages to come. The good mathematician, he was anticipating that if the rate of generating languages keeps going on, 700 programming languages will happen. Every day we can create a language, every 2 days we can create a compiler. Writing up the context free grammar is so easy and so steady now, we understand that. What is necessary is to make sure that the language features are strong enough to tackle the kind of complexity we are anticipating. We can write toy languages, toy programs, we can keep on doing it. There are also languages we can write programs. Program is easy, but software engineering to address a complexity requires that next step which takes us miles away from a simple programming idea. We have done good programming, we have done a lot of lines of code, but let us go back to the idea of comparing based on concept. It is a very standard way in which academicians do things. We have compared so many things, it is not antithetic to what we are doing, but then this is what we did earlier on in one of the lectures. We said that there are so many concepts, this is about 11 concepts are there, and we are talking about 7 languages: Effect, Smalltalk, Ruby, Java, C#, C++, Python, sorry, it is appearing as Python. So, now what is the problem? The problem is all these languages were done very recent, they are very young languages compared to Smalltalk. In the area of object oriented, the one that takes the maximum credits for being a pioneer in many things, many of these concept implementation is Smalltalk. Today's lecture is on Smalltalk, it was in 1980. All other languages happened much later, they are all recent languages, very young languages. Effect is a language which not many of us have. There are so many such languages which not many of us were teaching, but then they are all there in learned literature. There is a very good work, ACM SIGPlan notices, ACM Special Interest Group on programming languages. They used to give lot of notices. Earlier on, when we were talking about teaching algorithms, which language is best? Should we write pseudocode? Should we do so many things? There was one language called Sparks. For some time it was good. For some time it was a very good idea. We talked about Sparks as a language, very simple features, just enough for writing up a program and understanding how the analysis of algorithms happens. Why do we need that kind of a language? We can use the notation and do the analysis, design and analysis of algorithms. It can be done in many ways. What is the way in which we are expressing the solution? if it is expressed in a high level language, we strongly believed that people will come in faster, the productivity will increase faster. So, we had given a thrust towards designing, developing and working with third generation languages, which are what are called high level languages. These are all high level languages. The one that came very early and it got maximum credits for being a pioneer in doing so many things in the area of object oriented, that is Smalltalk. Please understand, object oriented became very popular 10 years later, 90. It became very popular. This language was there in 1980, which is the other method. One method is what is typically done by the research fraternity. We talk about doing this many concepts are there, we understand the impact of this concept. If inheritance is there, we think, oh, this is like that. If pointer arithmetic is there, we think something like this. If it is not there, we think something else. We understand the scoping of a language based on 11 core concepts. Other researcher may tell why 11, you can have 20. These debates have been going on ad infinitum, and we allow them to go on. There are so many debates about quality factors. How many quality factors? These are not likely to end also. That is how we progress. Next best idea may happen from all these deliberations, which might have been happening for ages. We would not know, a good idea will come. So, C++ is scoring very heavily, Java is scoring very heavily. So, we think that for the curriculum it does good to have C++, because what are are not the top domain, top rung features. These are all there, even if they are not there, it is a good language. So, for teaching we think this is good, C++ is good because it compares, it scores well on many other very many important object oriented concepts. So, a decision can be made, even though we keep arguing that there is nothing much to be taught in a language. It is learned through solving problems, problem solving, puzzle solving, the same terminology, the same thing. We have developed more and more programs. There is another method which is called TUBE, the importance of being earnest. TUBE, that is how it is expanded, the importance of being earnest, is specialized in assessing and tracking the quality of software. It is essential, whatever software we build. We measure the quality of a software system by applying widely accepted coding standards. This is a very good idea, very refreshing, because the only way in which we were managing quality for so long has been through what are called quality factors, quality frameworks, a process definition. This is something which we have been looking at it a level below coding. Coding will be the focus. It is a good idea. What you write as a code in a program will also tell the kind of a quality. It is true that even earlier on, like I discussed in the lecture on verification and validation, we do have software inspection, we do have code walkthroughs, but this is something which is slightly different. We will see why it is different. TUBE software was founded in 1st August October 2000 with an aid of a major investment of a Swiss company and some private investors. TUBE stands for the importance of being earnest. This is also the name of a comedy play written by Oscar Wilde at the end of the 19th century. It is a very good play, you can read it up. It strikes, it is a very good way you remember this. By choosing this name, the founders of TUBE software emphasize their sincere and professional attitude towards customers, suppliers and colleagues. That is what we are striving to do. And when we are talking about so much of UML, so many diagrams, 9 diagrams, 11 things, it becomes a bit of a bother for non-programmers, particularly those who are not so good on visual. We are very good on text, most of us are good on text. Visual is something which is a different medium to understand. There are people who are very strong on visuals, but by and large text is very appealing. Most of us are managing with text. Most employees of TUBE are compiler technology specialists who started their careers in research labs of Philips Electronics. TUBE's core technology to construct fast and reliable code checkers and beautifiers is based on elegant compiler generated tool set for Philips. TUBE checks more than 1056 million lines of software code for its customers worldwide, real time each day. 1056 million lines. What is the story about? We write code, but then we forget to indent. Writing a C code requires some kind of a discipline. The C code should be written in a manner where different things stand out differently. So, what we did in the world of Unix way back in 70s, early 70s, 71 is that we created what is called a C beautifier, which was not acceptable in academic schools. We were never allowing students to use C beautifier, do not use debuggers. So, what we were expected to do was follow the indentation rules. There is no excuse from that, maybe harsh, but there is no way, you have to follow the indentation rules. If this is a loop, if it is a loop within a loop, it has to go inside, within a loop you have to go inside. Automatically you will know how many nestings you can have, how the code becomes readable. Readability as a quality factor is very important, even though we know that nobody has time to read all those code lines. We are very quick, based on input and output we take a decision, but we are not likely to sit down and read through the code lines and then find out whether it is still manageable or not. That is the job of a quality assurance team. If they can spend time on software inspections and code walkthroughs, there is nothing like it. So, it was a good exercise. TUBE was a very nice ally to the Philips Electronics, and this was a good exercise of doing something like once they anticipated. Today I think it has reached this scale. They were talking about so many millions of lines of software code every day. Every day we should be able to test it. It was a target at some point in time. TUBE Programming Community Index definition, July 2020 is the latest. I should have indicated the latest is July 2020. What they do is, based on this methodology, it is ranked. All programming languages are ranked. July 2020 it is clearly Java that is reigning supreme again, and please understand that they are different. When we were talking about OO concepts, we simply ticked saying that this has maximum number of compliance to the OO concepts, therefore we use this language to teaching. Java is effective, overall effectiveness. There are 25 search engines that are used to calculate the TUBE index. How do you select a search engine? Which search engine gets the approval? Only these many criteria are used. Please understand that you have to use each of these criteria on every search engine. There are 25 different search engines that qualify. The entry page of a site contains a search facility. The result of querying the site contains an indication of the number of page hits. The result should be available in HTML with clear tags. Search engines in languages with special characters should be encoded properly. The search engine should at least return one hit for every query. The results of querying the site, all these are very nice. This is a good idea which was very instrumental in making many organizations think of a web presence. It is a good idea to have a web presence, because the search engine will determine the first level about the organization. Now, if you are making any serious application or anything, they will say what is the URL, please give the URL, please do the same thing, that is the first level. It is a very good indicator, and we have selected carefully a methodology for picking 25 search engines. TUBE indexing, what counts as a programming language? For the TUBE index, there are 3 requirements that should all hold. The languages should have an own entry on Wikipedia, it must be there. There is a reason why Ruby on Rails, Excel, Android, Boost, Cocoa, ASP, Ajax are not. So, if it is not on Wikipedia, it is not a candidate language for us. Good, bad, right, wrong, TUBE people do that. So, we strongly believe as academicians that let us go back to the concept. The foundations are in the concepts of OO. Whichever language matches maximum number of concepts, that is ideal for teaching, if at all you want to teach a programming language. Ideally, it is the problem on hand that should dictate which language should be used. The customers say this is the language. Every new language is tons of inventory in an organization of every stakeholder. So, we are very wary, we do not want to create too many new skills, too many new things. It is a commercial world which has given us the fillip in the area of this method of TUBE. The programming language should be Turing complete, I have mentioned all this, should have at least 5000 hits for plus language programming for Google. On Google you should have 5000 hits minimum, then that language is a candidate language. So, we have decided which is the candidate search engine, we have decided which is the candidate language based on a search engine called Google. The fact sheet, the TUBE coding standard TICS, it is like this. The TQI score is something which is very essential. higher quality is A, F is a very prolongated quality. It is like that, F is always on the lower rung and it has to be flagged like that. What is a negative gets flagged up in this method. That is their method. TUBE checks more than 1056 million lines of code, customers worldwide, real time each day, based on the ISO 25010 standard about software quality, measuring 350 standardized aspects automatically. Result is a score between 100 level A and 0 level F. Methodology is called TUBE quality indicator. You can push all the languages through this indicator, you will get some grade on all these aspects. Based on it, we rank the language. This year, this July 2020, Java has come back. The computer language benchmark game, this is another method. The third method, the computer language benchmarks game, formerly called the Great Computer Language Shootout, is a free software project for comparing how a given subset of simple algorithms can be implemented in various popular languages. This question is addressed day in and day out in teaching institutions, in development organizations. Every software engineer asks this question at one point or the other every time when they are looking at effort. Did I choose a language which is correct for the problem? Am I simply getting bogged down in the language, forgetting where the problem is? The question keeps on recurring, and this is another nice idea. Third idea, the computer language benchmark game. A set of very simple algorithmic problems, various implementations of the above problems, 13 if I remember right, next slide will tell, 13 sample problems are there. You solve these 13 sample problems and submit it to this benchmarker. The benchmarker uses certain criteria called overall user runtime, peak memory allocation, z-zip size, sum of total CPU time, individual CPU utilization, and automatically it will tell this language is better, this language, it is a comparator. CLBG is a very good one. Very recently I was trying out my hand on for the mobile application development. These days Kotlin has been chosen. Well, it's the maker of Kotlin that has been telling that we will all migrate to Kotlin while we retain. However, it was a very good exercise of comparing Java and Kotlin, and we think that there is something that we need to look into it. They try this CLBG metric, which is very quick. It tells that it is very efficient because in a mobile world performance is absolutely necessary. Imagine that you take so much time for an application to connect. Mobile, the expectation is in a Ziffy, everything should happen in a Ziffy. The moment you take a call, it should go through. The moment you want to do it Ziff, the expectations are very high. So, as of now, the CLBG metric is doing well, but then it is a case of an understanding. We will have to do some exercise of comparing languages. Kotlin is emerging very sleek on mobiles, mobile development platforms. It is very fast, very quick on performance, nothing to beat it so far, tailored for mobile environments. Java is everything for everybody. We can do tailoring, but this is ready made. You will get the efficiency very quickly. So, therefore, what is the concern here? The concern here is that this many things have been happening in the field of object oriented analysis and design, even though UML has emerged to be synonymous with OOAD, and there are plenty of tools. Even today, we need to take a look at the programming languages. That is how we started. Software engineering essentially is about understanding the beginnings of programming, the programming language, and towards that extent we still want to look at the same method of comparison. I discussed 3 different very current ways in which we compare languages, so that we understand better. It may be to answer a question, if at all we decide to teach a language, teach a programming language, which programming language? Simple question. Whereas in the commercial world, too many considerations, many considerations. What is so special about TUBE? The fact that it turns over 1056 million lines of software code. No quality assurance team can come anywhere close to this. Code inspection, code walkthrough, and it is a nice method. It has generated lot of interest, lot of critique. It has been criticized well critiqued. However, there are lacunae. For example, how did you select the search engine? Why only 25? There are 500 search engines. Likewise, there are so many languages that do not have a Wikipedia page. then it is not qualified for us. So, we have taken some views saying that there are certain gating criteria. These are called gating criteria. Whatever comes within this gating criteria, it is used. Within the ambit of this gating criteria, the language ranking has been happening. TICS is a fact sheet. This is how it is. A is maximum 100%, F is 0, and based on what is called the coding standard, whichever language you give, millions, 1056 million lines of code. On the sheer number of lines of code, nothing to beat this method, TIOB. The next one is computer language benchmark game. Choose a language, develop 13 programs, submit it. It will tell you based on exactly 5 parameters which is a language that fits the bill. So, use any of these, you can select a language, but what is the essence of today's submission? What was designed in 1980 and named Smalltalk reigns supreme. It is considered one of the best language designs. Why? We will see in the next lecture. Thank you.
Thank you.